Hello, everyone. Let's share my screen. And today we're gonna talk about the advanced hash collisions. As if shattered was not an advanced hash collisions. Let's make stuff more complex than shattered. Okay, so very funnily, just after the SHA-1 shattered release, there was this comic that I loved. Hey, they found a SHA-1 collision. No one here use it. We know it isn't secure. You see, told you it was good to use MD5 instead of SHA-1. And I actually asked for permission to reuse this stuff in various examples because I love these comics. So yeah, anyway. So in the previous stream, I discussed about what did I discuss about? About hash collisions, fast call, Unicoll, blah blah, shambles, hash clash, shatter, tumbles, the different kinds of collisions: identical prefix, chosen prefix, and reusable chosen prefix mixed with IPCs, so IPC as CPCs, and on various formats. So now let's move to yeah, of course, we're gonna rely a lot on my GitHub repository, github.com/corky/collisions. And also now we're gonna just jump on a presentation I did in 2017, just after, a couple of months after the SHA-1, the shattered release, because I did a bit more than shattered. So what could be more advanced than shattered? Because shattered, as we saw last time, was exploiting these are the slides, exploiting SHA-1 in a PDF, right? So what could we do more? It's just a standard PDF document, and there is a JPEG that is ambiguous, that has two versions of it. Now, any PDF element can be part of a JPEG, and you can have basically, yeah, this is totally standard element. And what could you do with that? And here, this is the paper of first collision of SHA-1, and actually I have it open here. It should be here. Oops, that was a giveaway. So the first collision for SHA-1, that's the actual paper. And what could be wrong? But no, that's not the paper, because there is a SHA-1 collision, and I replace my name with Marcel Dupont. And so how is it possible? Because there was only one computation of the SHA-1 paper. Because basically, I put my name as a picture. Here is a JPEG, and the JPEG is just put here at the right place. So it's not text anymore. Or at least what we see is the JPEG on top of it. And what can we do then? So you craft an image, and here I was cheeky that I actually use a double image, and for this part I'm displaying just a piece of the image, a crop view of that image. And if I looked here, page 6, there is a diagram, and this has been replaced by the comic you saw earlier. But this is what I do. It was an image that was used in two places with different cropping, and these two files have SHA-1 colliding from the same, exactly with the same prefix. Of course, I didn't rerun a new SHA-1 prefix computation just for that. Now, what else? What's JPEG? JPEG is an image format, and not actually in the case of PDF. JPEG in the case of PDF is just a compression, which means you have PDF stream objects and they use compression. And this compression is the DCT decode, which means a direct cosinus transform decode. That's what it stands for. And basically, JPEG is just a compression. And in few readers, like Adobe and Sumatra, for example, well, it's still possible to store actual data. Like actual data of the page content is stored by the with the JPEG compression. But JPEG is lossy, right? Okay. But wait, if you store JPEG with quality 100 and you use a grayscale JPEG, which means it doesn't have to mix RGB together, so no risk of loss, then it's still a bit lossy, slightly lossy, but JPEG is 8x8 block base. So basically repeat the content lines eight times, and you have to pad to prevent truncation. So you just have to align stuff, and actually JPEG can be turned lossless in a very clumsy way, which means it works. So for example, in my case, these two files, very simple vector files, extremely tiny. What's their size? Their size is 195 bytes. So you see, this is again the same SHA-1 prefix that we saw last time. And here you have the shattered block collision. So just the same prefix and just a JPEG, but this time the JPEG image is not being referenced as an image in the code, but the content objects, the content of the page is object one, and object one is the image. And is there filters? Yes, there is a filter object, because I made it. I'm not sure if it was pure luck or if it was planned. I don't remember now. Probably it was planned anyway, in case. So basically, oh no, it's sorry. I realized now that it was yeah, it felt easy. So DCT decode here is the JPEG decompression. So basically, the content of that page is totally standard, as we saw earlier, PDF operators, but they are stored under JPEG compilation, and it can be abused with the shattered prefix. And they are displayed, but browsers don't accept this kind of tricks typically. So other tools like pure PDF viewers like Sumatra or Adobe actually works. So just an example. What was it? Clipped one. As you see, this is the page. And here you see that my fake name is displayed in a very different way. We can see with zooming out that it's displayed differently, right? But I mean, who would notice that? When you zoom, it's hard to notice that it's a JPEG and not actual text being displayed. Okay, and Adobe decided to crash, because why not? Okay, so you can abuse the JPEG. You can abuse the you can reuse the shattered prefix for stuff that is actually page content. So what could you do with that? Well, you can do some stuff that is even nicer. You can even do some art. And where is it? Yes. So these two files are colliding. So the if poem from Rudyard Kipling and this stuff that I drew in vector. And it's funny because you have colors, even though it's a grayscale image compression. But yeah, it works. And now, so this shows that you can do more just with the same prefix again. And this time you have complete different page content that is stored in a JPEG under a collision. JPEG as image, JPEG as data, why not both? And indeed, just have some stuff that is used for both. So pad data to match the image width, store 8 times to make lossless. The image can be lossy, but the data should be preserved, right? Because it will be used as page content. Again, you can apply DCT decode compression to any stream objects, and usually those are fonts, JPEG font, images, and embedded objects and page contents. So append image, and the page content can reference itself. You don't have a page content terminator, so yeah, it's a bit tricky. You need to be lucky or to try enough. And this is exactly what I did. I took very nice grayscale pictures that I like, Golden Axe in Sega Master System, and this width here is the page code, basically the page content, which just says, hey, define a graphic state, start a graphic state. Here are the dimensions, reference object image one, and also do something with the color 10, so RGB, so pure red. Start text, select font F1 in size 90, go to this XY coordinates, and display the text golden axe. And this is exactly what I did. And so basically, these two images have a SHA-1 collision, and they are used as both page content, the loss repeated 8 times, so this is lossless in a JPEG, and also an image. So yeah, that's just to show that you can go crazy, but you can try many kinds of proof of concept. So that's it for the Shattered++, where I display more stuff. Now, inside out. As we saw last time, as we saw, zip, XML, and tar, we will see, are not generically exploitable, but we can do some stuff, some workaround. And this is another, as you can see, all these files are openable under Adobe too. And so now we'll work with the slides from that are presented in 2022. And basically, the story starts like this: that I was asked. Hey, these file formats, are you sure you cannot do anything? And as I told you, when you have, you need to prove, when you have something that uses MD5 and is not broken, people are still using MD5 anyway. And it's like you have to prove them if it's still broken. And this is exactly what happened. In 2022 or something, libtiff was still announcing its releases by MD5. And they were tar.gz or zip. What could go wrong? And so I was shocked, but then what could I do? Try to think and some ideas, and then at the end, party. But not that easy, because and also there is some company that I will name here that index Office files, modern Office files, which are XML files in zips. They index Office files with MD5. Like, how bad is it actually? Yeah, it's MD5, but can we prove them wrong, and like really, really wrong, as in instant reusable collision for these formats? And at the time, it felt impossible technically. Like, if you saw my latest stream, it would seem impossible to instantly collide these files formats. So there's no easy way to abuse XML, tar, JZip, or zip. JZip, or maybe, but what about tar.gzip and docx? Docx, which is zip XML, basically. XML isn't exploitable, but we make, because it's in zip, it will actually be possible. And uncommon JZips are actually exploitable, but I didn't know that back then. So a small recap on hash collisions. So for all the existing standard hashes, even MD2 and further, and more recent, there is no practical pre-image attack. So basically, you give an arbitrary hash. You cannot say, hey, here is the file that I give me something that has the same hash, this given hash. The attack is like, make two files with some arbitrary contents. You don't control everything, of course, to get the same hash. So basically, it's what I call buy one, get one free risk. You get file one validated, and file two, which has the same hash, is reusable, and the system that index files like this way will not be able to tell the difference. So basically, if you get a clean build as a PDF, and it's what you expected, so you whitelist it by hash, and then basically malicious Windows executable could have the same hash, because if both the kill and the bill were prepared so that they were built together to get the same hash. It's not something you can get. It's not with a given build.pdf you can get a kill.exe with the same hash. It doesn't work that way. You have to build the two contents together. And in the other example, much more complex, but also very powerful, you get a Benin certificate signed, and then that gets you full power certificate signed. So basically, you can decrypt everything everywhere, or something like this. The problem is that both files need to be valid, if possible with all parsers, and if possible permanently, as in not exploiting a bug that should be fixed, like something permanent. And the actual examples of hash collision structures are with there is always a prefix that is optional, but usually it's there. And the prefix, in the case of identical prefix, well, it's exactly the same on both sides. Then there is some padding, and in the case of chosen prefix, the prefix can be different. Then there is some padding to put all these prefix with padding to the same length. Then comes some collision blocks, which will be the same length on both sides, but will have tiny difference, and these blocks are full of randomness, like the content is unpredictable. And then after that, after these collision blocks, the two files, despite the minor differences in collision blocks, and in the case of chosen prefix, the differences in prefix, the hash will be the same after these collision blocks. That's the goal of hash collisions. And whatever you add after these collision blocks on both sides, if you add the same thing on both sides, then the hash stay constant on both sides, even if it's updated, obviously. The suffix is optional. So now you have an idea of the structure of the two structures of hash collisions: identical prefix or chosen prefix, IPCs and CPCs. For an IPC, it looks like this. You have something like a prefix. Here is a file with a few bytes. Then you have some padding, and these collisions work with blocks of 64 bytes, so 40 in hex, so 4 lines of standard hex view. Oops. And so that there is an alignment, and then comes the collision blocks. You will see that their content will be extremely random looking, and there are tiny differences. Here there's an F, here there's a 7, here there's a 4, and so on and so on. And the differences are the same across the two blocks. Here we have two differences next to each other, but it's actually the same difference because the difference is a mathematical operation on the whole 32 bits. So basically, there can be some carryover. That's all. Like plus or minus, you get the idea. And the suffix has to be identical on both sides too. For a chosen prefix, you can put whatever you want as prefix, yes or no, but the prefix can also have very different length, total different content. It's just there will be some padding so that they have the exact same length. And some bytes at the end of the padding are reserved for a part of the attack. Then there will be a number of blocks, again, blocks of 40 bytes in hex. And usually more than 2, but anyway, you see 9 is a good result for quick computation. The fewer the blocks, the more computation extensive, and then suffix. Unicoll is a small exception to that, made by Mark Stevens too. And it has the ability that you can put some stuff, you can put some control some data inside the collision block before and after the first difference, and the difference is predictable. So the 10th character will have +1. So basically, you can say if it's a Y, it will be a Z, and so on. You can make puns with that. For example, there was a poem in the previous stream that was using IPC Unicoll. Okay, so as we saw, this collisions work. The hashes work from the start to the end, and you can update whatever you want at the end. And the collision blocks depend on the actual prefix before. If there is this single bit difference change in the prefix, then the computation has to be run again. There is no shortcut for that. And since most formats are passed top-down and iterate upon the data of any length of any content, which means at the end of the official definition of the format, you can put whatever you want, it's trivial to do a chosen prefix collision on a single player. You take 2 files, and then you run hash clash. This is the name of this collision, and then you will get 2 files with appended collision blocks, and the file will be valid because if this format tolerates appended data, and then you get it instantly. I mean, not instantly. It will take a few hours or something. But yeah, that's all. So what else should there be to demonstrate? The problem is that zip is parsed bottom up. So if you have some data after the zip, it could be a problem. Now, XML and JZip don't like appended data. XML doesn't like appended data at all, and JZip will throw a warning. And zip will only work with 64 kilobytes of appended data at most, which means if the zip and the other file have a very big size difference, then with the collision block and the padding, if the prefix is the zip and then there is the padding and there's a collision block and the other file is much bigger, then you will the zip with the appended data will not work anymore. So basically, zip XML and JZip aren't hash collision friendly, even standard hash collision, not even just reusable. So the idea is for a standard case via just chosen prefix, you take some computation, but you have to repeat for every pair of files. While in the case of MD5 and some file tricks, then you can pre-compute prefixes, which may take the same time, but maybe needed only once. And then you just need to redo some file manipulation with new files to do a new pair of colliding files. So basically, some file tricks and some clever thinking, and then you have reusable thing. You can reuse that for any pair of files. The layout of a reusable collision, as we saw, usually there is some signature. You first abuse some command to align things. Then you declare a command that will act as a switch to turn on and off a bigger command. But here is where the hash collision is. So basically, this command will be bigger or longer. And then you add another command that will cover the whole content of a first file, which will make it ignored or not by by the parser. Now, let's try to see zip archives and see what's the problem. So this is a simple zip archive. And there are three structures: local file header, one per file; central directory, one per file; archived in the one per file archived in the archive in the whole file. And then there's central directory, one per archive at the end of the file. And they have to follow this order. All the local file headers first, then the central directories indexing the local file headers, then the end of central directory that points to the first central directory. This is how it works. It's a bottom-up chain, and it's a list of central directories, and it's also a list of local file headers following each other. So when the zip is created, the local file headers are written first, then the central directories, then the end of central directories, then the unique end of central directory. There are a few existing algorithms in the wild. The correct one is locate end of central directory from the last 64 kilobyte, parse the central directories, and go on, so on. But some tools decided just parse the local file headers and ignore the things. So we can't abuse zip structure and stay fully compatible. We cannot do, if we play a trick on a specific zip implementation, it will not work on everything. And now, zip parsers are tolerant, but the end of central directory is parsed in last 64 kilobyte. So basically, if the other file of the pair is too big, then again, the end of central directory will be too close from the end, which means the file won't be parsed. So bottom-up formats are naturally collision resistant. So generate collision with zips? Nope. So and another problem is that all of the data is duplicated between the local file header and the central directory. Like you see, it's the same block. And very importantly, there is a CRC, and there is compressed size and the file name length. All this is present twice. And the problem is that the data that you want to abuse, the file data, is in the middle. So basically, if you wanted to update this data, then you have to replicate the CRC of this data and the length of this data is written before this data and after this data, which makes it impossible to exploit with a hash collision. So this is a problem. Another reason why we cannot use generic hash collisions, we cannot have a prefix that will work for every data because the length is stored there and the CRC and even the compression. And for maximum compatibility, of course, you might try not to set them in one, or for example, the central directory. Some tool will use the file name that is here and not the file name that is here, but it is unpredictable and unreliable across the zip parser landscape. So for maximum compatibility, these sets have to be constant across colliding files. So again, zip structure prevent generic reuse. So zip is very annoying for hash collisions. Now, what's a docx file? It's an archive, a zip archive of several files with subdirectories. There are mostly importantly and always some XML files, PNGs and JPEGs and images and so on. And there is a root file in the subdirectory _rels relationships, sorry. And this is what points to the main doc file. So that's a that's a small relationship file. And you see that it points to the actual, Word document, another XML in the file. So can we make two document coexist in the same archive and pointing them with under different directories? Yes. You point to each document via the root, and the root, by this way, if it's Word 1 and Word 2 or document, then the root will the root file, the relationships file, have a constant length. Now the problem is that if we change the content, we need to have collision blocks, and we need to hide them properly in the zip. And the problem we saw is that whatever you hide in the zip, there will be a CRC of the content before. So here it's here, first copy of the CRC and second copy of the CRC between around the data. So even if you would have collision blocks here, you would have a problem of the CRCs changed. And you also need that even if you change the content of the file, then you need the CRC to be constant. So XML in collisions, you can have commands in a XML, but the encoding UTF-8 is still enforced even in commands. So it's one of those commands that you cannot put whatever binary you want. And here, this is the simplest collision ever on a single block. And you see it has a very high entropy, And basically, XML is totally unhappy if you put that in an XML command. So if you put the collision blocks in another archived file, it works because there will be a constant length of the blocks and the CRCs, but the file CRCs has to be present after the data too. So just use a dummy file, an extra file in the zip, and you store the content not as file data, which is supervised by which has its CRC in the two headers, central directories and local file headers, but instead store the content in the extra field, which is not controlled by CRC. And now you just need to hide this extra dummy block, the extra dummy file, in the whole archive. So basically, you need to tell OpenOffice or Office that this file exists. You just need to declare it as a dummy file, as a whatever binary data, so that the file doesn't say, hey, there's this data in archive and I don't know what it is. That's easy. So extra field in zip is standard. It's been defined in local file headers since 1990, and it's commonly used. So very often it's used for something like timestamp or extra information or NTFS content. So basically, extra fields are standard and they're usually preserved. And each field uses an ID, and the unsupported IDs are just ignored, which is exactly what we want. So now we need to have a constant CRC, even though we slightly changed the file. So we kind of need to have a CRC collision at the same time that we have an MD5 collision. And basically there is a good tool for that, which enables you to makes it possible that you just give it a string and it will give you the same string under it has a cryptic command line syntax. And then, for example, this will have the right CRC just by mixing lowercase and uppercase of the sentence you gave. Or you can say, hey, I want a shorter string, and but it has to be ASCII, and I want this CRC. So basically, for arbitrary content, you say, this is exactly what I did. I added A for one file and B for one file. I changed word 1 and word 2, and then I asked CRC hack to give me to make those two files having the CRC of Coffee Babe, just by changing the case, lowercase and uppercase of this string here. So the constant CRC problem is solved. Now it's actually funny because usually a prefix, zip prefix, no, a collision prefix is an invalid file because you have a header without the body. But here it's more like we have actually local file header, and whatever is update oh, I forgot to mention, let's go back, but the extra field is stored right before the content. Oh, this is weird. It's not stored after. Okay. Oh no, so just before the content. But anyway, we don't care because our file or dummy file will have a name and no content, but the extra field will be right after it. So basically, our prefix of zip prefix is basically an actual file that is stored in a standard way in a zip, and the hash collisions data is stored in a local in the extra field. So the rest of the file can be built normally, and basically your initial archive works as a file, even though it's more than a prefix. So it's actually funny because you can start with your doc files, you can add whatever file you want. You just need to add, you need some special command line to make sure that there's no extra timestamp or whatever. But as long as you just add the same file to your colliding file, then the hash stays the same. And if you remove the extra file that you added, since the local file header will be preserved, and the local file headers means colliding data and collision blocks in the extra field, then you revert back to the original file. So it's actually very interesting that these collision prefixes are behaving like normal zips, as long as you do some manipulation within the same 2 seconds, because there is a timestamp, or you use a special command line to override the timestamp writing. And I wrote a tool that just takes zips and tries to detect the format, and then I created let's see, I created let's see, GitHub Kokami scripts, the insider, and I created all kinds of prefixes, and the prefixes are already available. So basically, you just run it. You just take two docx file, completely different if you want. It doesn't matter. It will find that it's a doc file. It will merge the two files together, and then it also need to update the content types, and then it starts to do its magic, and basically, do the collision for you, and it takes less than a second because it's just file manipulation. There is no need of heavy recomputation at all. It's just moving stuff around. And other formats that are based on XML and in zips are also exploitable. And I computed the prefix for those. So EPUB, XPC. XPC is the Microsoft attempt to do something like PDF. 3MF, which is standard for 3D printers. All these formats are based on zip and XML. So basically, they are exploitable too. So you just need the insider. It would be extensible to any other formats like this with the same tricks. Some formats that may look similar but are not, like Quake PK3, there's no root file to abuse. Open document format, you have a manifest that mentions every other file, so basically you cannot make generic in advance. And APK, jar, and XPI. XPI is Firefox extension, if I recall correctly. It's even worse. You not only it mentions every other files, but it's also mentioned the hashes. So it's totally not generic. So let's look at the insider pre-archive, as I called it. So basically, this is a valid zip, right? It's just that it's not a full zip yet, but it's just exactly all that it needs. Then the files need to be added, but this is just the structure of the collision. So it's a zip archive containing a root XML file that we can see here, and I made it in stored. So the byte here says that there is no compression. So basically, that means that the length will not vary. There will not be a recompression. And then here we have another file, blocks, that is that has no content, but then there is an extra field. And here I said AP. I'm not sure why, or whatever, the for extra field. And then comes the collision blocks. So there is the answer of central directory. There are two central directories, and there are two local file headers, one for the root document. So here, fxdoc, it's for XPC, if I recall correctly. It's not for a Word document or whatever. Can we see XML, Microsoft, XPC, XPS, sorry. XPS, yes. So fxdoc.fdoc is the root of an XPS file. You see that the schema is here. And then there is empty block file that contains the collision blocks, but that is empty. I mean, it doesn't contain it. Its local file headers does. Now, we have fixed doc sequence that is present twice, but the extra fields have no CRC, which is good. And now here are the way that from a collision perspective, here is the prefix with the whole first local file headers with the document, with tiny differences of the XML root path changing to 1 or 2, and then there is the CRC32 manipulation to make sure that these two files have the same CRC. And then there is the padding, then the collision blocks, and after the first local file headers, there is a second local file header for the empty block files, and the collision blocks is in the extra field. And the suffix is whatever you want to update afterwards. You can make it a valid zip, of course. That's the goal. So after this, the root file has a constant CRC and length, so no need to change the local file headers. And the collision file has a constant CRC, MD5, because it's empty, and no content change because the collision blocks are stored in extra field and not in compressed data. So that's all we need for complete exploitation via hash collision of zip and XML. We abuse the root XML document of the file to we abuse the root element XML document, and we how can I say? And then we can append whatever we want. We just need to reshuffle the data of the two documents in the same archive. Now, no questions. tar.gzip. Tape archive tar is quite old. Not very old, it depends. It's a sequence of file headers and file contents. There is no compression. There is always a file header, file content, and everything is aligned to 512 byte blocks. And to end the archive, you will have two empty blocks of 512 bytes at the end, after the last file. It's not enforced, it's not required, but it will make any appended data ignored. Okay, whatever, not very important, because here not exploitable. So this is the header of a tar file. It starts with the file name at offset 0. So already we have some non-generic thing. And then it starts with stuff that depends at hard-coded offsets, and the octals, the integers are in octal, and there's a checksum that needs to be updated for the tar valid to be valid, and the checksum is computed over the whole header, and then there's a signature, which is the thing that comes after all this. That is the thing that says it's a tar. So, but what makes a valid tar is there is a signature at offset 100 something, and there is the valid checksum, and then each element has hard-coded offsets. Very old structure, and this header checksum is certainly enforced. And the end of the header should be empty, even though there you still have a lot of bytes. They should be empty. If there is something that it's usually seen, oh, it's probably not a tar, because tars always have these zeros. So that's why typically tar are compressed with something like JZip, zstandard, whatever, XZ, bzip2, because tar is again for tape archives. It's totally not for compression. So collision and tar, it's a top-down format with appended data. Okay, it's compatible with chosen prefix, but there's no way to put comments anywhere in the offset. All the offsets are hard-coded, so no reusable collisions. Now, what's a tar JZip? It's just a tar archive, the whole tar containing many files, and compressed with JZip. The tar ignores what's happening in the JZip layer. So abusing whatever is in JZip, it won't interfere as long as the original tar content is decompressed fine. So this is a very minimal JZip archive, and the data for the compression on JZip is always deflate. So basically, the minimal data is here to say this is an empty JZip, and the length of the uncompressed data is at the end, and it's 00, and in this case it's 0. So that's the minimum, very minimum file, and this is 30 just says data, no data. So we see that it's not storing, even if it's empty data. It means there is some definition because it's using deflate. It's not storing when zip is storing files as is. It's not using deflate. Deflate is still modifying stuff. So you can always pad something with an empty non-compressed blocks. You can always add 5 bytes to extend something, but no content can be skipped. So this block means empty deflate block, but nothing can be skipped. So collision blocks can be abusing compressed data. Now, funnily, it's the same trick we're going to abuse. There is an extra field in JZip. There is a bit to set, and then after the OS flag, it starts with the length, and then it's data. And the length is on 2 bytes. The extra field is supposed to be a sequence of subfields. It's not really enforced. You can still put whatever you want as long as the structure is enforced. But in practice, it will be like, this is the length of the whole extra field. Then there is a subfield ID. Then there is a sublength for this subfield, and comes let's say the subdata, the data of the subfield. So typically, there are very few extra fields actually defined. One of them is, for example, the Apollo file, Apollo computer, not the the spaceship. So it exists. Another use that is interesting is the GZip, which is a zip that is made so that you can multi-thread decompress. You can access different parts of data of the GZip, because here everything is in a single block of data. So we can put collision blocks in extra field, and it feels like a pattern, even though the formats have nothing in common. So you give an extra field, a variable length, and then you can get a different data to be parsed or skipped. But because it's only 2 bytes, this will be you may be able to skip something, but only skipped. You can only skip up to 64 kilobytes. It works, but it's limiting. And but again, this is exactly the same constraint of size like in the shattered exploitation, because JPEG commands also have their length stored on 2 bytes. But what is actually a JZip file? Okay, weird. And most JZip files are stored of a single member. Members can be concatenated, and each member will be decompressed, and data will be silently decompressed and concatenated. Decompressed data will be concatenated, which makes it possible with the BZip thing that I mentioned earlier, to have data stored in different members and have each member decompressed in parallel, and then the data being concatenated. So this is a single empty member as again with an empty content. And this is exactly the same thing. It's just two members being empty. And you can even put some zeros as long as it's null between the members, and it's fine. So these two files are equivalent. Okay, what could we do with that? So basically, but remember that we can store an extra field in a member, even in an empty member. I mean, a member with empty data to decompress. Or the data won't be empty, but the uncompressed data will be officially empty. So members can, yeah, exactly. That's what I just said. Non-types or extra field are ignored. So basically, an empty member is like a classic comment where you can put whatever data. So classic collision exploitation is possible. And you can see it as a header, the body with a subfield, and the footer is just an empty data body, and then the header, the CRC32, and the length of the uncompressed length, which is null. So basically, you have some kind of format where you could put whatever you want here in an extra field. And then you can just do this automatically. You insert members with no data to skip other members, and you basically skip exactly like I did for exactly like I did for shattered, for JPEG, because again, extra fields length is on 2 bytes, and JPEG length is on comment segment are on 2 bytes too. So you just interleave 2 chains of comments keeping each other data, and then you can put arbitrary length data and chunking it on 64 kilobytes. So now Unicoll can be used with chosen prefix collision. Again, Unicoll works on +1 on the 10th byte of the collision block, and is faster than chosen prefix. So you use one member for Unicoll alignment, then one member declared at the start of the Unicoll blocks. So this is a Unicoll-based JZip collision with some ASCII art in the middle, and the timestamp, okay, which I've used to put my name, because why not? The extra field ID, and then the text of the extra field to align. So that's my collision block extra field, subfield ID. And then there is the data to make stuff perfectly aligned, so that what's happening, we will have the length of the extra field perfectly aligned with the collision, with the Unicoll difference here. This is the Unicoll block here, and the difference, the length of 76 will be 176 in the other case, for the case of the other file. So let's go back. Then we have some filling text, and we will land this extra field will extend to this length or plus 100, depending on the version of the collision block. And then we can use this to resume the content of the file. So from a Unicoll perspective, this is the identical prefix, and this is the Unicoll block, which has some chosen text before and after the only difference. And then there is the post Unicoll trampoline to land from different jumps from here or here, 100 more. And after, we interleave the content of the two files. And from a GZip structure, we have one member for Unicoll alignment, one member that will have a variable length because it's the one with the collision block, with the Unicoll collision block. And then the other members to land from the collision blocks. Then the first content of the file, this one just says hello. And then there is a terminator, which I wrote, as I mentioned before. If between two members you have some non-null bytes, then the JZip parsing will stop. So if the JZip parsing goes here, then this will be decompressed. This member will be decompressed, and then it meets AA. Oh, this is not the 1F8B signature of a JZip. Let's stop parsing the file any further. And if with the other jump, with the other version of the collision block, we land further in the file and we decompress the other file which contains by. So this is the flow for one version of the site with the terminator with the non-null bytes that stops the parsing. And in the other case, we jump a bit further and we jump over this and we end up parsing the other file. So I supplied, this is Unicoll, but I still provided pre-computed prefixes. They are available on the website, of course, with the script. And you can take whatever you want, libJPEG turbo and libtiff.tar.gz. You need to split everything in members so that the members don't exceed 64 kilobytes, and that just does the trick. And it's instant and it works. And then the tar just sees via the GZip and zip decompression, just sees a different tar altogether. So initially I thought it was no collision and now it's instant collision on both formats. So it's colliding arbitrary set of files, whatever, JZip, tar.gz. It will work with other JZip based formats and zip of XML in zip with the root document as XML. And it works with this. I already wrote it for this format, but other formats can be added, no problem, with the same technique. It's two very different exploitation strategy. In one case, you have the same archive, two different root files that are inside the archive, and both set of files are together. And in the other case, you have two different archives of independent tar files interleaved together. Sorry, taking a drink. The tricks and compatibility. So in one case, we abuse the root document. We store the collision blocks in dummy file. We make sure the dummy file is seen by the system by adding it to content types XML. Then we keep the length and CRC constant for generic reuse, and we merge the two documents in different paths in the archive. In the other case, it's very different. We abuse the JZip structure to deliver different tar archives. We abuse empty members as command with data in the extra field, and we interleave both archives as chains of commands, two chains of skipping over the other chain, and then some data, a bit of data. The compatibility in the case of zip is very good because extra field is fully supported and preserved, and the GZip root, no problem, mostly supported. I'm not sure why so mostly. And standard collision POCs are very malleable, controllable. You can do operations on it. It's still a valid zip. It's very funny that it stays colliding even though you manipulate it with standard tools. On the other hand, JZip, the extra field is fully supported and preserved, but the extra members mostly supported. Some software like Inkscape, they don't tolerate SVG, Z, so JZipped SVG to be stored on extra members. And usually when you save a JZip with extra members, it will be most likely it will be rewritten as a single member. So basically, in this case, the preservation of this colliding proof of concept will not be is not guaranteed at all. The file will be rewritten and will lose its colliding properties. That's the common case, right? It's more like it's the exception is for zip, that even if you do standard operations, it still collides. And any change will of this is a standard zip. This is a very not standard JZip. And of course, as usual, this trick done for MD5 will also work for other hashes with the same construct. So as Mark joked, fastcall is the free demo and SHA-1 it's a paid cloud service. And indeed, I can do that at home with a small computer with MD5. And but then this technique could be reused if someone is willing to do the computation for SHA-1. Stuff for SHA-1 is already available, and probably well, I don't know what's next. So both tricks rely on extra fields. It's standard and undocumented. And there's usually no scrutiny, so there's no bugs to fix. Compatibility is good. They can be scanned or removed. There is no needed recompression to remove them. You just move stuff around. If you want to do a security tool to prevent that, check for known IDs, the length and the entropy of the extra field. And multiple members in GZip is detectable, but is standard and maybe not so common, so maybe no one checks for it. And after that, libtiff stopped mentioning MD5s for the releases. So remember, this is everything you have on my repository, probably more by now. And don't play with fire. Don't rely on MD5. Now, what time is it? Oh, okay. I think that's enough for today. I will do a third one then. I will do a third one because I still wanted to cover hash coins and detecting hash collisions. Okay, so we covered more advanced versions of JPEG, of shattered files. So these JPEGs used as image and content. Oh, error exists on the page. Oh no, but it's still open. Oh, okay. It makes a mistake if you click on it, but it still opens. Okay, thank you, Adobe. I don't know if you ever had seen JPEGs with data and image in the same file, and this is the page content that refers to this image, and it works. And I'm still surprised it still works in 2025, right? I did that in 2017. That's some time ago. Okay, so and then we looked at more advanced collisions, zip and XML and tar.gz, which I thought were impossible, and it requires a bit out of the box thinking, and with some clever tricks and extra fields in both cases. So yeah, looks like I'll do another stream on hash coins and detecting hash collisions in the future. So I thank you for your attention, and yeah, I guess see you next stream. I see no comments. I had no. It's very rare that I have no Q&A. So yeah, see you next stream, everyone. Bye bye.